The instantaneous rate of change of a function is called its derivative, and it's defined as follows. The definition of the derivative is if we have that f of x at x equals c is the limit of the difference of quotients if it exists, meaning f prime of f of x is equal to the limit when h approaches to 0 of f of x plus h minus f of x divided by h. When this limit exists, we say that f is differentiable at the point x equals c. And this there's an equivalent definition of the derivative that we call it the alternative form. Definition of the derivative that it's exactly the same meaning. Okay, so we have that f prime of c is equal to the limit when x approaches to c of f of x minus f of c divided by x minus c. Okay, so we're going to use these definitions for the next problem. Okay, so we have that a diver jumps from a diving board that is 32 feet above the water. The position of the diver from the water is given by s of t equals negative 16t squared plus 16t plus 32, where t is measured in seconds. We need to graph this function on your graphing calculator and sketch the result below. Okay, so we realize that basically we have 32 is going to be the y-intercept because how the function is defined. Okay, so you have that s of 0 is going to be equal to 32. Okay, so I'm going to name this 10, 20, 30. My 32 is somewhere here. This is going to be 40. Okay, you know that it's a parabola facing down because of the shape of the function and all the characteristics that you have. So we have something like this. Okay, and the intersection is happening at 2. Okay, the x-intersection. We know that there's another x-intersect, but the time cannot be negative, so we really don't care about the other time. Okay, so your function looks like this. Okay, for b, we need to find the average velocity. Okay, or the average rate of change at which the diver is moving from the time interval 1, h plus 1. Okay, so what we know is that the average velocity is going to be s of h plus 1 minus s of 1, everything divided by what? H plus 1 minus 1. Okay, so we cancel out those, of course. After that, we plug it, the h plus 1 and the 1 over here. Okay, so we are going to have something that looks like this. Negative 16 times h plus 1 squared plus 16 times h plus 1 plus 32, and that's the first part. Then you need to be careful because we are going to have a negative that it's affecting s of 1. Okay, so this one is going to be positive 16, okay, times 1 squared minus 16 times 1 minus 32. Okay, so if you see, I distribute the negative there because I don't have enough space. Okay, so you have that this is going to be divided by h. Okay, so let's take a look at what we have here. Okay, when we expand this, this is going to be negative 16h squared, okay, minus 32h minus 16. Okay, this one over here, you know that it's going to be plus 16h plus 16, and the rest stays the same. Okay, so you have a bunch of things that cancel. This cancels with this one with 1 over here. This 16h will combine. Okay, this 16 cancels with this one combines with this one. Okay, so what do you have? Okay, so let's see what we have. We have negative 16h squared that we have over here. We combine these two, so we have negative 16h. Okay, and that's pretty much it. Okay, so then you have it divided by h. Okay, so then you realize these two have common factor of h, so I can cancel the h. Okay, take it as a common factor, and you have negative 16h minus 16, and that's it. Okay, so that's going to be your average velocity. Now, if we use this result to estimate the instantaneous rate of change at which the diver is moving at time t equals 1, what you know is that the instantaneous velocity, following the definition of the derivative, you know that the limit when h goes to 0 of negative 16h minus 16, what's going to be that one? Well, you plug the 0, super easy limit, and you know that it's negative 16 feet per second. And that's pretty much it. Given f of x equals x squared minus 4x, we need to sketch the graph of the function and the tangent line to the graph at the point where x equals 3. Okay, so since we're talking about x equals 3, I'm already going to compute f of 3. F of 3, what's going to be f of 3 is going to be negative 3. Okay, so because you know that it's 9 minus 12, okay? So let's graph it. How can we graph this equation? We know that is, well, you can see it like this, x minus 4. Okay, so it's pretty easy to see the x-intercepts that you have at 0, and let's graph it here, 1, 2, 3, 4. Okay, so at 4 is going to be your other intersect. Okay, and then the vertex is going to be at 4, well, 2, 4, so we have 1, 3, 4. Okay, so we have that. My parabola is going to look something like this. Okay, so you have this equation. Okay, but more specifically, they are asking you about a point. Okay, so you would know that 3, 3, well, let's do the theory of big dots here. Okay, so 3, 3 is there. Okay, so what's the tangent line? Okay, the tangent line is going to be a line that slightly touches this point, which is 3, negative 3, right? So the tangent line is going to be this line that we have over here. That's going to be the tangent line. Okay? We can draw it more specifically once we have more information, but that one is going to be my tangent line. Okay, so based on your sketch, do you expect f prime of 3 to be positive or negative? What are you going to look when you're looking for the derivative? The slope. What's up with the slope of this line? It's not perfect, this line, but what's the slope? Positive. Okay, so we know that it's going to be positive. Okay, so since the slope of the tangent line okay, is positive, okay, we know that f prime of 3, or the derivative evaluated at 3, is positive. Okay. So for C, what we need to do is we need to compute f prime of 3 in 3 different ways. Let's do the first way. The first way is going to be the definition of the derivative, which is the limit when h goes to 0 of f of x plus h minus f of x divided by h. Okay, so you have that this is going to be equal to the limit when h goes to 0 of, and you have that it's h plus x squared, okay, minus 4 times x plus h, and then change the sign, minus x squared plus 4x, and everything divided by h. After that, you are like, okay, so this is going to be the limit when h goes to 0, and then expand that situation, so you have that it's going to be x squared plus 2xh plus h squared minus 4x plus 4h minus x squared plus 4x, everything divided by h. And here some things happen. This one cancels with this one, this guy cancels with this one, and last but not least, you cannot cancel that one. Okay, that's fine. Okay, so we have 3 things that are surviving my cancellation. Okay, but the 3 things, what happens with them? All of them have the h, so I can take them out. So I have 2x plus h plus 4 divided by h. Cancel the h's, so you have that this is going to be the limit when h approaches to 0 of 2x plus h plus 4, which you know that this is going to be what? 2x minus 4. Okay, and that's going to be basically this is going to be f prime of x. Okay, moreover, if we are looking of f prime of 3, what happens? This is going to be equal to plug the 3 there, so it's going to be 6 minus 4, which is 2. Okay, now for C part 2, okay, what you need to do by using the alternative form, okay, so the alternative form, let's see the alternative form of the definition. You know that it's the limit when x approaches to 3, okay, of f of x minus f of 3, and you're going to see that this one is not as long as the previous one, okay. This is going to be equal to what? X squared minus 4x, and then when you plug the 3 there, we already said that it was negative 3, so it's plus 3 divided by, and I forgot to write my limit, so let's do it again. So the limit when x approaches to 3 of, what was it, x squared minus 4x plus 3 divided by x minus 3. After that you're like, oh, a quadratic, awesome, I can factor, okay, so factor that equation, x minus 1, x plus 3 divided by x minus 3, and this one should be minus, I don't know why I put plus, okay, so you just put the negative here, okay, cancel, cancel, and surprise, surprise, what do you have? 3 minus 1, which is equal to 2, and boom, it was the same, okay, so you have that, this is the same, surprise, surprise, okay. For C3, we're going to use the shortcut. What is the shortcut? Okay, if you didn't learn the shortcut, well, it's pretty neat, okay. Let me explain you what you want to do. Okay, so when you take the derivative of this equation, okay, let me show you this equation. You are looking for the exponent. The exponent you are going to multiply times the coefficient, which is 2 times 1, which is 2. And then the power of the x goes down by 1. So you have that f prime of x is going to be equal to 2x for the first part. And for the second part, you are going to do exactly the same thing. What's the exponent? 1 times negative 4 is negative 4. If this one that it's exponent 1 takes, you take a negative 1, then it would be 0. So this variable disappears very technically. So you have that this is negative 4, and that's going to be your derivative. Okay. After that, you're like, okay, I need to evaluate this at 3, and surprise, surprise, what do you have? Exactly the same value. So as you can see, there's 3 different ways to compute the derivative, and they are as valid. For the last part that we have here, let me put it there, write the equation of the tangent line to the graph y equals f of x at x equals 3. Leave your equation in point slope form. What are you going to do? Y minus y1. Okay, so you already have the x1 and the y1. Why? Because you already know that x is 3, okay, and your y is negative 3, okay, so you already have your point. Okay, so let's organize. You have the point 3, negative 3 from the original, okay, and we already have the slope, right? What's the slope? The slope is going to be equal to 2. So super easy. What are you going to do? Plug your information into your equation. So the equation of the tangent line, okay, to the graph of f, okay, at x equals 3 is, surprise, surprise, y minus or plus equals 2 times x minus 3, and that's it.